Uh, Hello student, welcome to this new lecture on hyperbolic function, and this is our seventh lecture. This lecture I will teach you the basic properties and graph of second hyperbolic x. Okay, in our previous lecture we discussed all the properties and the graph of fourth hyperbolic x, and these are the properties. Okay, that we have already discussed in our previous lecture. So go through this previous lecture and watch it. If you have any doubt, then comment your doubt in the comment section. Okay, in this lecture we will discuss the basic properties of second hyperbolic x. Basically, second hyperbolic x is the reciprocal of the hyperbolic cosine hyperbolic function. It is important in hyperbolic geometry, complex analysis, and signal processing. Okay. Now, sec hyperbolic x is an even function. Okay, because we saw that the sec hyperbolic of minus x is equal to sec hyperbolic of x. This is very easy. Uh, let f of x is equal to sec hyperbolic x. Okay. Now f of minus x is equal to sec hyperbolic of minus x, and this can be written as 1 by cos hyperbolic of minus x. And we know that since the cos hyperbolic x is an even function, so this is equal to cos hyperbolic x. This is equal to cos hyperbolic x, and 1 by cos hyperbolic x is equal to sec hyperbolic x. This is equal to f of x. Here we saw that f of minus x is equal to f of x implies that f of x is an even function. Okay. Now, what is the domain of sec hyperbolic x? Basically, the domain is by um, the e to the power x plus e to the power minus x. The denominator of sec hyperbolic x never zero for all value of x. Since the expression is defined for all value of x, so the domain of the function sec hyperbolic x is since uh, since cos hyperbolic x is always greater than or equal to 1 for all real value of x, the sec hyperbolic x is always defined, and this is always positive. Uh, Cos hyperbolic x is always greater than or equal to 1 implies that 1 by cos hyperbolic x is always positive. Is always okay. Now, what is the range of sec hyperbolic x? Uh, Basically, the range is semi open and close interval, 0 open and 1 close. Basically, this is the range of sec hyperbolic x. Why? Uh, Observe from the graph. This is the graph for sec hyperbolic x. So here we see that sec hyperbolic x is a bounded function, and this is also a smooth continuous function. Okay, this is bounded function, and this is a smooth continuous function. Okay, it is a bounded and a smooth function defined over entire real line. Okay, so since the domain is R, the function is defined over all the real number. Okay, now why the range is basically open and close interval 0, 1. Semi-open, semi-close of interval 0, 1. Why? Basically, this formula for sec hyperbolic x, this is equal to 1 by cos hyperbolic x. Okay. And we know that cos hyperbolic x is greater than or equal to 1 for all value of x. Okay, so basically the minimum value of cos hyperbolic x is equal to 1. So here this can be written as like 1 less or equal to cos hyperbolic x, and this is less than infinity, very large quantity. Okay. So if we take the reciprocal, so the reciprocal of 1 is 1, and the reciprocal of cos hyperbolic x, this is equal to sec hyperbolic of x, and the reciprocal of infinity, basically this is tends to 0, so this is 0. And if you take the reciprocal, then the inequality sign is changed. So the sign is basically like this. Or we can write like this: 0 less than sec hyperbolic x, and this is less or equal to 1. Here 0 is not included, so upon in this side 0. So here 1 is included, so one side is closed. So the range is basically 0 open and 1 close. This is the range of sec hyperbolic x. Okay. Now, what is the limiting behavior? If you take the limit x tends to infinity, what is the value of sec hyperbolic x? Uh, Basically, sec hyperbolic x, limit x tends to infinity, sec hyperbolic x, this is equal to limit x tends to infinity, this is 1 by cos hyperbolic x. Okay. And we know that as x tends to infinity, cos hyperbolic x goes to infinity. So 1 by infinity goes to 0. So this value is tends to 0, and this is 0 positive. Okay. Similarly, if we take limit x tends to minus infinity, sec hyperbolic x also goes to 0 positive. Okay, this is very easy. So I will leave it for your homework. Okay, now what is the maximum value? Basically, the maximum value of uh, sec hyperbolic x is equal to 1. This is at x is equal to 0. Okay, because the range is basically 0 and 1, and then 1 is the maximum value. Okay, now this is the graph of sec hyperbolic x, and the function is symmetric about y-axis, because this is a even function, and we know that every even function is symmetric about y-axis. Since this is an even function and this is symmetric about origin, this is not a one-one function. Okay, and we know that the horizontal line test, if we draw horizontal line, then there exists a horizontal line which is intersect the graph exactly 2 points. Since the horizontal line intersect the graph at 2 points by horizontal line test, we can conclude that this is not a one-one function. Okay, now it attains the maximum value at x is equal to 0. At is equal to 0, the maximum value of sec hyperbolic x is equal to 1. Okay. And as x tends to infinity or x tends to minus infinity, x tends to infinity or x tends to minus infinity, the graph approaches to 0 positive. Okay. Graph approaching to 0 positive. And the range is basically 0, 1. Semi-open, semi-closed interval 0, 1. Okay. This is the graph of sec hyperbolic x. Now, what is sec 0? Sec hyperbolic 0. This is basically 1 by cos hyperbolic 0. Okay. This is basically, or directly you can use here the formula. By formula, this is 0 by e to the power 0 cos e to the power minus 0. This is basically 1. Okay. Now, limit x tends to infinity, sec x is equal to, this is equal to approaching to 0. And what is the value of sec 1 and what is the value of sec minus 2? This is your homework. Try to solve this. Okay. Here is sec 1 and here is a sec hyperbolic 1 and here is sec hyperbolic minus 2. Okay. Remember one thing, the value of sec hyperbolic x is always positive. Also, cos hyperbolic x is always greater than or equal to 1. Okay. So remind one thing here, the sec hyperbolic x is a bounded function. Remember one thing also, tan hyperbolic x is also a bounded function. Okay. Now, the monotonicity behavior of sec hyperbolic x. Basically, the sec hyperbolic x is equal to 1 by cos hyperbolic x. Then the derivative of sec hyperbolic x is equal to minus sec hyperbolic x into tan hyperbolic x. Okay. Similarly, the derivative of, we know that the derivative of sec x is equal to, basically this is minus sec x into tan x. Similarly, here the derivative of sec hyperbolic x is minus sec hyperbolic x into tan hyperbolic x. And from the graph, we see that for some value of x, the graph is in the left hand side of y-axis, and for some value of x, the graph uh, is right hand side of the y-axis. Okay, but for all value of x, the graph is above x-axis. So for all value of x, the graph is positive. Acha. Look one thing. Here is a negative sign. Okay, here is a negative sign. But here is the derivative. The derivative of sec hyperbolic x is equal to minus sec x into 10x. What is the graph of 10 hyperbolic x? Basically, the graph of 10 hyperbolic x is equal to this is like this. Okay. For some value of x, the graph is in below the x-axis, and for some value of x, the graph is above the x-axis. So the 10 hyperbolic x is positive for some value of x and negative for some value of x. And here is also a negative sign. Okay, but sec x is always positive. When 10x, when 10 hyperbolic x is negative, here is the one a negative sign, negative and negative is positive. The when the derivative is positive, then the original function is increasing. Okay. If it 10x is 10 hyperbolic x is positive, then here is a negative sign. Negative into positive equal to negative sign. If when the derivative is negative, then the graph is increasing. Okay. Look the graph from here to here. From minus infinity to zero, the graph is in increasing mode, and from zero to infinity, the graph is in decreasing mode. Okay. So when x is positive, when x is positive, 10 hyperbolic x is positive, 10 hyperbolic x is positive. So the whole quantity, this is negative, this is positive, and this is positive. The whole quantity is in negative. So the derivative is negative when x is positive. Okay, the derivative is positive. Sorry, the derivative is negative because the 10 hyperbolic x is positive. Sec hyperbolic x is always positive. Here is the negative sign. The whole quantity is negative. Okay. If the derivative is negative, then uh, when x is positive, the graph is in decreasing mode. So sec x is decreasing on 0 to infinity. And here is a negative sign. Sec hyperbolic x is positive when x is negative, and when x is negative, 10 hyperbolic x is negative. Okay. So here is a negative sign, here is a negative sign, negative, negative, positive. So the derivative is positive when x is negative. So sec hyperbolic x is increasing, increasing on minus infinity to zero. Okay. ଦେଖ ଏଠି ମୁଁ କଣ କହିଲି ଦେଖ ଯେହେତୁ ଏଠି ନେଗେଟିଭ ସାଇନ୍ ଅଛି ଦେଖ ଯେତେବେଳେ x ଟା କଣ ହବ ପଜିଟିଭ ହଉଛି sec hyperbolic x is always positive 10 hyperbolic x is positive negative into positive so basically this becomes negative ଏଇଟା ନେଗେଟିଭ ହେଇଗଲା ଯଦି ଡେରିଭେଟିଭ ଟା ନେଗେଟିଭ ହେଲା ତାହେଲେ ସେଇ ଇଣ୍ଟରଭାଲ କଣ ହେଇଯିବ ଡିକ୍ରିଜିଂ ନେକ୍ସଟ ଇଣ୍ଟରଭାଲ ସେଟା ପଜିଟିଭ ହଉଛି ତ ସେଠି ହେବ ଇନକ୍ରିଜିଂ ଓକେ hence sec hyperbolic x is strictly decreasing on upon interval 0 to infinity and strictly increasing on minus infinity to 0 with a global maximum at x is equal to 0 and the maximum value is 1 at x is equal to 0. This is the global maximum. Okay. Now, injectivity or a 1-1 property. So basically, this is not a 1-1 function over R because it is symmetric about y-axis. By horizontal line test, we can conclude that this is not a one-on function over R because the horizontal line intersect the graph at 2 points. Okay, and if we restrict the domain like 0 to infinity or minus infinity to 0, then in that domain, this is a one-one function. Okay, now what about the onto-ness property? Uh, if we define sec hyperbolic function from R to upon 0 and 1 closed interval, then in that case, this is a onto function. This is a surjective function. We define sec hyperbolic x from minus infinity to 0 close and 2 upon 0 and 1 close interval, then in that case this is a bisective function. Okay, this is all about the properties and the graph of sec hyperbolic x. So read the summary and remember all these things. Okay, this is all about today's lecture. I'll see you soon in the next lecture. Thank you and happy learning.